So what if you could solve our trash problem and our energy problem at the exact same time? Today, we're diving into a job that aims to do just that. It's called the Sovereign Power Technician, a role that's part waste manager, part power plant operator, and, maybe a little bit of the future.
This right here, this is the core idea, the promise that this whole field is built on. I mean, just imagine turning a landfill into a power station. It's a really bold vision, but how in the world does it actually work?
Well, to make that promise a reality, you need this person. This is the operator, the mechanic. You could almost call them a modern alchemist who stands between a giant pile of trash and a community with its lights on. They're the key to the whole thing. So let's talk about why this role is so critical right now. It wasn't just invented for fun. It was designed to tackle two massive, and I mean massive, problems at once. Problems that, really, affect all of us. Think about it. On one hand, you've got these ever-growing mountains of waste, plastics, garbage, you name it. And on the other hand, we have these huge, centralized power grids that are becoming more and more fragile. So, what if you could use one of those problems to solve the other one? And that, right there, is the whole idea behind this machine. This is the engine at the heart of this new trade. And its purpose is actually deceptively simple. It eats trash. Okay, so the technical term is a micro gas-to-liquid system, or micro-GTL. But here's the important part. Unlike a traditional power plant that plugs into some massive grid, this thing is designed for the exact opposite. It's built to let a small community, or a farm, or an outpost completely cut the cord and make its own power, right where it's needed. So how does it do it? It's basically a four-step process. First, you process the feedstock, and yeah, that's literally just trash. Then you hit it with superheated plasma, which basically vaporizes it, breaking it down at a molecular level. That process creates a really valuable fuel called syngas, and then in the final step, you use that syngas to generate both electricity and liquid fuels. Simple, right? And this is what's so brilliant about the setup. It's incredibly flexible. You're not just making electricity to keep the lights on right now, you're also creating a stable liquid fuel, kind of like diesel, that you can stick in a tank and save for later, or use to run trucks and tractors. It's energy on demand, and it's energy for the future, all from the same box.
Okay, so what's the science that makes this all possible? The source manuals for this system call it the alchemy of plasma, and honestly, that's a pretty fitting description for what's happening inside this machine.
The core principle is something called plasma gasification. Now, you probably remember from school that there are three states of matter: solid, liquid, and gas. Well, plasma is the fourth state, and it's even hotter than gas. By creating a controlled plasma arc, you can essentially vaporize waste, but you're not burning it. You're literally tearing its molecules apart.
The training manuals for this have a fantastic analogy. They call the plasma torch a molecular scissor. I love that. It's not a clumsy hammer, it's a precision tool. It doesn't just burn the trash, it goes in and precisely snips the bonds holding all those molecules together. And that's what cleanly releases all that trapped energy. So, if the machine is the forge, who's the smith? This brings us right back to the human element, the person who's been trained to manage this incredible and frankly dangerous power. The Sovereign Power Technician, or SPT for short, isn't some physicist in a lab coat. They're a hands-on tradesperson for a new world. They're the ones diagnosing the weird noise, mixing up the right recipe of waste, and at the end of the day, they are the ones keeping the lights on. And you have to understand, the stakes for this job are unbelievably high. The reactor core inside that machine operates at over 1,500 degrees Celsius. We are talking about some serious industrial-grade hardware here. And because of that danger, because of that raw power, the requirements to get certified are, well, they're absolute. To even qualify to run one of these things, you have to get a perfect score on one very specific test. They call the training safety-gated. And what that means is you literally cannot access the modules on how to operate the machine or how to maintain it until you have scored a perfect 100% on all the safety protocols. There is absolutely zero room for error. So how on earth do you train for a job with stakes that high? Will you do it virtually? Before a technician ever touches the real machine, they spend hours and hours in what's called the AgriSim. It's a complete physics simulation of the reactor. They can practice everything from a routine cold start to handling a sudden catastrophic system failure, all in perfect safety. And that simulator is just one piece of their digital toolkit. They have the master manual, which is basically the 300-page Bible for the system. They have the AgriSim for practice. And get this, they have an AI assistant called Remnant. They could literally take a photo of some broken part, and the AI will identify it and then walk them through the entire replacement process.
Okay, so we have the machine, we have the science, and we have the technician. Let's zoom out. Why does this combination matter so much when we think about the future?
There's a line from the source material that just sums it up perfectly. This isn't passive renewable energy, right? It's active, on-demand power. The system isn't just sitting there waiting for the conditions to be right. The technician is the one who creates the conditions by turning a local problem, trash, into a local solution, energy.
Ultimately, this is about way more than just a new job. It's about creating a whole new kind of local economy, a waste-to-value economy. It's a trade that doesn't just earn a living for one person, it actually builds self-sufficiency and resilience for an entire community, from the ground up.
So it really leaves us with one final thought to chew on. As our huge, centralized systems seem to get more and more fragile, maybe the answer isn't just another big, top-down solution. Maybe it's just a skilled individual tending to the flame.